Greetings to you all. I'm Derek Korn, Editor-in-Chief of Production Machining Magazine. Welcome to Programming Swiss Type and Multitasking Machines for Maximum Efficiency, a webinar sponsored by SolidCAM. Thanks for joining us. SolidCAM has evolved its CAD/CAM software to provide a CAM solution for all CNC machines, including turn mills and Swiss types. Today's presenter, Ken Merritt, SolidCAM's Director of Special CAM Projects, will describe new software features that have enabled this type of advanced machining to perform at higher speeds and efficiency while simplifying programming. He'll also touch on multi-channel sync functionality, tool management, machine simulation, and more. Today's presentation will be followed by a Q&A session. It's easy to submit questions, and I encourage you to do so during the presentation. Simply type your question into the question pane on your screen, and we'll do our best to get to all of them. So let's get started. Ken, please take it away.
Well, thank you. I appreciate that. Thank you all for joining us today. Welcome to our webinar on our SolidCAM Advanced Mill Turn and Swiss Type, which is also known as sliding head machine programming. And with me today is also Mark Stokes from our United Kingdom division, and they will be doing the live presentation for us and guiding us through some of that. I'd like to take you through a brief PowerPoint just to kind of give you an idea of who the company is and kind of what we're about, and then we'll hand it over for the presentation. So to begin with, SolidCAM is a fairly large organization. We're worldwide. As you can see, we've got numerous offices all over the world here. Quite a few seats out there in the world. A lot of people using the software and liking it. And some of our tech centers around the world are actually quite advanced. We do a lot of work with the machine and program. This is one of the things that gives SolidCAM kind of an edge, if you will, on some of the other competition out there, is that we actually test the software on machining centers and use that to make sure that we are doing a really good continuous improvement with our software. So we're going to be coming to you live today from the tech center over in the UK, and that's going to be kind of interesting to see. Now, SolidCAM is an integrated CAM system, and we mean fully integrated. We work directly inside the SolidWorks and Inventor UIs and allows us to generate our toolpath algorithms on the actual model. We're not doing this on imported files. We can, of course, use imported files in those CAD systems, but this gives us the ability to be fully integrated and work directly off the solid faces and the solid edge entity IDs for full associativity. Okay, and we launched our program many years ago. SolidCAM has been around for a long time. We have been a part of the gold certified program with SolidWorks and the certified program with Inventor for many years, as you can see here. The other thing that we have a lot of distribution around the world, a lot of experts that work with us. And so we want to that truly integrated functionality, where we are following the requirements of the CAD system and making a very unified approach to the user experience. Okay. This is some of our modules, our options in the system, and we can sell it in full a la carte, or we can sell it in groupings, what we call packages, that make sense for you as a user. No need to sell you more than what you need. We want to facilitate your needs in your shop. Here's a brief listing of some of our customers and some of the different areas of the market that we excel in. We work with everything from mom and pop shops all the way up to, as you can see in here, some Fortune 500 companies and very big organizations. Education is also a very big function for us, and we provide software for educational facilities worldwide. One of the things that we're really proud of, if you'd like to take a look on our website, you will see lots and lots of customer testimony, lots of customer review. And who better to hear from than the people who are using SolidCAM on a regular basis. So please feel free to join us on on our webpage and take a look at any of that. Now, support is another area where SolidCAM has really focused a lot of our effort, a lot of our concern, and a lot of our investment. One of the areas on our website that you will see is the customer review area. Now, service is very important to us. And so we have live technical support engineers who have a minimum of 10 years of machining experience that are available to handle any questions that you may have about the system. They also work with training. There's numerous different ways of doing training. We've got some free online training all the way up to on-site at your facility. Okay. We also have SolidCAM professor training videos that are available. And there's literally hundreds of online tutorials that are available 24/7. Okay. And so one of the things that we would like you to look at is those reviews, because most of those reviews are absolutely talking about the support that our customers get from our team of experts. Now, this is our UK office. This is the group over in England, and they're going to be showing us a Star CNC. I'm going to hand this over to Mark right now to let him tell you a little bit more about their facility and what they do over there.
Thanks, Ken. Welcome to the SolidCAM UK Technology Centre. We've got this has been set up in the UK for 6-7 years now. We've had various machines in here. We work very closely with a lot of suppliers, and we've got very good relationships. Historically, we've used Romy machines from Brazil, and we've got 3-axis machine just over there, which will be changed for a 5-axis in the next couple of weeks. And recently, we've done a lot of work with Star in the UK, and we've had the SR38 in here up until about 3 or 4 months ago, when they changed it over for the machine which we see here, which is the ST20. So we've got a very, very good relationship. Now, the reason for having technology centres, as Ken said, is not just to show the software, it's to show solutions as well. So we'll work with a lot of solution partners for tooling, for work holding and everything else on there, and have seminars to show that. It obviously shows SolidCAM in the best light then, because we can show it and prove the claims which we have, especially with things like the eye machining, and now obviously with the Swiss type of sliding head machines. So this particular machine we've got in here, which we're going to be working on today, is the ST20, which, if you can see on the graphic on the slide, is not like your traditional sliding head, which works on tool platens. This one's got 3 turrets on there, which gives us more challenges in a way. This is a 12-axis machine we're working on. We've got multiple areas where we've got dual axis, so we've got 2 Z-axis is working together. So whereas if traditional sliding head machines have their own issues and their own problems which we have to come across, this is a slightly different one and gives us more challenges to work with as well. But hopefully over the next sort of half an hour, we'll be able to show you how we conquer those and how easy it is to actually utilize the full capabilities of the machine.
Great. Thank you, Mark. I really appreciate that. And Mark's got some really powerful stuff to show you here in just a few moments. You can always connect with us at www.solidcam.com. And of course, on the right side of the screen there, you can see our phone number to check in with us. Extension 2 takes you to the sales department. And we're ready to go, I believe. So, Mark, let's go ahead and switch over to your system, and let's start talking about what SolidCAM can provide. Now, while Mark is switching over, I want you guys to understand that the development in SolidCAM has been accelerated really rapidly over the last 5 years, working specifically towards these multifunction, very advanced machines. And Mark's going to show us a lot of detail in that. If you have any questions after, please write them down or plug them into the Q&A session here in the webinar, and we will try to address those the best we can at the end of this presentation. Mark, you got it.
Okay, this is the part we're going to machine. It's very difficult to actually see on here, but you'll see a lot more of it, what's going on. So there's multiple challenges in there. We've got some engraving on there. We've got some quite complex features actually happening. So while I'm doing the presentation, we'll actually be machining this in the background. So just excuse me just while I just go and check things out, and we'll set that running. Okay. We're away. So, excuse me while I just put my headphones back in, and I'll be able to hear everything. Okay, so I want to run through how it's actually all working and what's going on. So Let me just bring up my screen so we can see what's actually happening. So where we are at the moment, this is just bringing up the part and we can see exactly what's going on. So this is already pre-programmed, but what I wanted to do is run through how it's programmed, where we're simplifying the complicated work, and really giving some idea of the ease of use and the power of SolidCAM. So first of all, as I explained right at the beginning, this is a slightly different format of Swiss turn machine on there, in the fact that it's a turret machine rather than a straight platen machine. Now, that gives us different challenges on there, but I want to show you straight away into here how this is actually understood by SolidCAM itself. So this is part of the machine setup, and this is showing how all the axes work. So we can see on there, for example, we've got a series of build-up of axis on there. So we've got like X1, Y1 on there, and in the background we've got the full machine, which we'll come back to in various points on there, so we can see exactly what's going on and how it's actually happening, and we can see how these are all built up together. So for example, we can look on there, we've got X3, Y3 and Z3 on the lower turret, which is this turret down here, and yet we've got X1 and Y1 on the turret up there, and obviously you've got Z1 on your main spindle coming this way. So we've got lots of axes working together. So it's very important that the software understands what's possible and what's not possible as we're working through the actual part. And it will help us on that front. For example, if we came across a machine which didn't have a Y-axis and we wanted to do some machining, it would automatically switch us into a C-axis mode. It would understand that based on obviously the kinematics which are built in here. So if I just move down a step, we've got this concept of submachines as well, so which takes the combination of possible axis use up here and combines them into more understandable groups on there as well. So if we're working on path 1, which is the top one, you can see on there, we're working with the upper turret and Z1. But then we've got different options on path 3. So when we're working with the lower turret, we could be working with path 3 and moving Z1, so moving the parts here. Or we could be moving with path 3 and using the independent Z-axis on the turret. So we have to understand how we can work with different modes on there. We've also got the possibility of working together. So we could be working on, for example, using Z1 with the upper turret and using Z3 on the same component on the lower turret. Obviously, Z3 then has to compensate its position based on the exact position of Z1 at that time, which is superimposition, which again we'll come to see later. So we see all that handled automatically inside SolidCAM. So that's then broken down. This particular machine is a 3-channel machine. So we've got 3 programs or 3 parts of the program which has to be generated. Again, SolidCAM understands all of that and will cope with that for us. So again, it's very little for the actual user to know. Yes, they still need to know the machine. You still need to know machining. SolidCAM's a tool at the end of the day to make your life easier. It's not going to take over. So that's the kinematic side of it. Then we can go into, there's a lots of things which else are important on these complex mill turn machines, whether it's a slider or a Swiss turn, or whether it's a straight standard, if you like, mill turn. If we're machining or have been machining, say, with the upper turret on here with a drill, say going axial here, and then we want to do some axial drilling on this one, we've got to move this one out of the way first, otherwise we've got a collision. So we need to have control over not just the cutting area, but the non-cutting movements of the machine as well. And we do that with what we call machine control operations. So these are predefined strategies on there, which are going to be used over and over again, just again to make the user's life much, much easier. That then brings us down to axis patterns down the bottom. Now on a star, we use them to make our life easier, but they are not, if you like, true axis patterns on a star. If we take that to a citizen, for example, then you've got G600, 610, 620s, and you've got a lot of dedicated axis patterns. They're described in terms of exactly what they do on the axis patterns in SolidCAM, and then when you come to use them, SolidCAM understands what each one of those codes means and each one of those codes does. So everything, again, is helped internally for you. So what we've seen at the moment on there is the machine definition in terms of how the machine is actually set up to make it work. One more area I just want to bring in, and we've got user-defined areas on here as well. So the first two areas are set up to make the machine function, but it's very important. I mean, we'll configure machines in the UK probably completely different to you may want over there in terms of output code. It can come down to local flavors. It could come down to, even if you like, the say for example in this case the star local engineer and how he sets his code up and how he's taught the customer. So we can customize the output of the code and flavor it. We're using the user-defined parameters on there. So all of this is very, very important. So I'm just going to come out of there and we'll have a quick look at some of the things we want to do and how it's actually programmed. So we have this setup option down here. So this is done right at the head of the program, just again to keep our life simple. And this gives us an excellent introduction to the visualization we have in SolidCAM. So on every operation, whether it's a machine control operation, whether it's a turning or milling operation, or even within the tool library itself, we have access to this machine preview. So we can see the current state of this or positions of all the axes at every point. So for a start on there, we've got nothing. We're starting from scratch. But if I zoom in on here, I can see the part sitting in the guide bush in the main spindle. Likewise, if I come over to the back and click on here, I can see the part in the subspindle. Now, the reason for doing that is we can set everything now in terms of pick-off location here. So I can very graphically see, okay, where do I want to grip this when I've done the transfer? And we can set that up visually either by scrolling the mouse wheel, which is what I've done, or typing in a value, and we can see that's where that subspindle is going to come up and pick the part from. Keep it visual, keep it simple.
And Mark, I'd like to interject in there just for a moment. Guys, I want you to think about something. A lot of our competition doesn't get to see this until after they have posted the code and they take it into the G-code simulation. What Mark's showing you right now is that throughout the entire programming process, you're going to be able to visualize what's going on and have a much better, more comfortable sense of how you're building your toolpaths.
Thanks. One of the things which I pointed out in the setup on there was the ability to move axis out the way and control those. So again, as Ken was saying, we have the ability to preview, so we can see where the machine is when we go into an operation. So we can see if we do need to move axis out the way. Again, it's all done up front. It's all done very clear. So just a very quick introduction, if you like, to machining on Swiss type sliding head machines. With a fixed head, you tend to work typically outside in. So you'll work on the outside diameters, your machine all this out the way, then maybe move on the inside. It's a typical method of work. You'll do all the outside work first and then work inside. Sliders or Swiss type are the reverse of that. Because it's supported by the guide bush, we have to be very careful about having excess movement or retraction in the Z-axis so that it doesn't fall out the guide bush. So it doesn't go back too far. The guide bush is typically about 15 millimeters wide. And if we take this too far back, it's going to rattle in here. That's our local support to make sure that it's secure and machining is very well supported locally to the part. So it's a different method of work, but say SolidCAM is going to give you the tools to do all of that. So let me just show you a very quick part of that. We've got some turning, which is working on the outside diameter here. So this is the dialog box for it in terms of how we program. So again, you can see very graphical. We can see the tool down here, but I just want to go to the geometry just for a start. So we've got our solid model here. And in terms of selecting geometry, let's just create this again so we can see what's actually happening. I'm not looking at any geometry on there apart from the actual part itself. So I'm picking the first and the last face, which I want to turn on there. And that is it. It is now that simple. I don't have to create any extra geometry. I don't have to extract any edges. I'm working directly on that solid model. So that's in there. We can do obviously what we like in here. Going to tooling. Now this is what I'm saying. At every point on there, we can see where we are. So if I go into the machine preview within here, we can now see it. And we can see it populated with all the tools around all the turrets, all the holders and everything else. And we'll come to that a little bit later in the presentation, how to put some of those in. But again, we're going in there. We can see exactly what tool we're using. and where it's situated. And if I zoom right in, we can also see the direction of rotation being demonstrated to us as well. So there's so much information straight in my face giving me this feedback straight away. You also saw in there, which I didn't highlight, which we'll come back to later, we're supporting all the multi-tool holders. So again, if you've got multi-stations on one holder, everything is supported up front in SolidCAM. So a couple of other little things I would just want to highlight in here. If I go to technology, well, this is the part which we're telling it how we want to machine it. So we're telling it sort of where to machine, what to use on it, and then how to machine it. And this layout is exactly the same in every dialog box in SolidCAM. So we're just going to rough this down, and we're going to finish it. And our strategies. So if we've got undercut areas we don't want the tool to try and go into, we don't have to create any bridging geometry or anything like that. We just turn the option on to stay out those areas. Now, as I was saying right at the beginning or a little while ago, we don't want the part to retract back too far onto a smaller diameter because it's going to fall out the guide machine, it's going to rattle on there. So one of the things we want to do, if we've got a long part and we do need to turn that way, and we need a long part to support it, we need it to come out, but we can't do that we could do that by breaking it up into different operations. So maybe go 10 millimeters rough finish, then go the next 10 millimeters rough finish. And we could do that with various operations. So we could build up a tree of operations, but we can also do it automatically inside SolidCAM. So this is now splitting that up. It will do rough and finish 10 millimeters, rough and finish 10 millimeters, keeping the bar moving forward rather than retracting it all the time. So you have specifics within SolidCAM to do all of this as well. So I'll just get that going. And then what we'll do is we'll have a look at a couple more operations on there so we can see exactly what we're doing. So you can see I've just put the new geometry on there, toolpaths being shown, we're all updated. Okay, so I'm going to jump down to a milling operation now, just to show you the power in terms of what we're doing with this. So we're going to go into, and I'm going to pick, say, not that one there. We're going to pick because I can show you a little bit more in this one. So again, we can edit into it. Now, what this is doing is machining this hole on the back. So this is machining this hole from the side. So in terms of geometry, if I actually look at the model, before I go in to see what's selected, we can see that this actual part, if I go look on the top, it's broken into 5 segments, whatever it is, 1, 2, 3, 4 segments. I can't count this time of night, but obviously that's broken down, which means I've got a little bit of picking to do. But SolidCAM isn't fussy; it's whatever's easiest. So what I've selected in here is the bottom edge. It's a single edge. It doesn't have to be planar geometry. It can be worked out in 3D, and SolidCAM internally projects it to 2D as required. So we've got that working onto this face. Again, we'll come into the tool, and if I go into select this, then we can see all the tool information coming through. Again, in here, let me just turn that one off for a minute, because this view is showing me the holder, and it's showing me that the tool's located in the holder correctly, but not a lot else. So I'm going to turn that one off and go and represent it. Now we can see it actually in the machine. So now we can see where it's actually located. We can see the tool orientation. Everything is in our face and ready for us to work with. So that's fine. We'll come out of there. And a couple of things on there. So we set the geometry to machine. And we're now going to go onto the page. As I say, this is how to machine it. And I've just set a depth of cut of 1/4 mil. So that's literally just going to take a load of steps down there. But on any shape, you can change it to helical. So on something like this, if I simulate what's going on, we'll just turn the toolpath on. We can see that's just going to do a 3D spiral. Nice and easy, straight down there. Again, everything's in our face, everything's easy to do. So we're just showing a couple of operations on there. We're going to show a couple more because there's a couple of things which fall outside that remit as well. So I'm just going to scroll down. We've cut some slots in the back of the part. We've cut these slots in these two slots on here, but we've got a chamfer around the top. We want to deburr them as well. Everything, certainly in our technology center here, we encourage every part, any programmer on the machines on there, every part has to come off fully deburred. If we're running seminars and people are picking parts up, the last thing we want is any sharp edges on it. And it's the most efficient way to do it. If we can do it on the machine, it's much better than somebody else sat there on the side deburring stuff. It's just manual work. You've got to have somebody do it, and it's time consuming, and it's never the same. So we encourage everybody to deburr things as we're going along. So if I pick up on that operation, which is this one here, we can see, if you like, looking at the tool path, it's actually following that edge going around. So we're actually using the C-axis to do this. We're rocking the C-axis on there to follow this and keeping the tool on center line. So how are we doing that? But if I come in to have a look at it and see exactly what we're doing, then subtle difference in terms of how we're setting up the geometry. So let me just recreate this for you. So I'm going to create some new geometry, and we're just going to create one of these. Now we've got an option here not to project it, but to keep it wrapped around a specific axis. So we can say, yeah, we're going to wrap this around a Z-axis. Don't flatten this for us. Use it as it is. So again, if I just select that, it's automatically picked the whole lot for us. We haven't got to worry about it. So that's how easy it is to extract the geometry. Now, because the geometry is wrapped, again, the tool's definition is set up the same way. We can see we're using a two-station holder on here. So we pick the right tool on there. But within what we call motion control, this is how the actual machine's behaving to it. It's automatically, and it won't let me come out of fourth axis because it knows the way I pick the geometry needs the fourth axis to actually work. So again, we'll have a look at that. We'll show some of that in simulation later, just so we can see exactly what's going on. So that's looking at some of the programming of it. I want to go into certainly one machine control operation. And this is one we use quite often. Well, we use it in pretty much every part, to be fair, because it's part of the transfer routine. And it's the back spindle approach. So this is connecting the subspindle. So if I look at it, it's very simple on there. All we've got is 3 positions because everything else is being controlled internally. So we're going to stand off the part, we're going to connect the part, and this is the feed rate. So very, very basic information. But this is where the machine preview really does look good because we can see exactly what's going on at every point. So the first thing, which has already happened on the tree, if I drag that away, is we selected the part off tool and position Z1. So before we've done anything, we can see that in its correct position. So now we can see our part off tool is sitting there ready to work. If I click onto our positions on here, it'll actually put the axis in the places we're looking at. So now we're stood off 5 millimeters on here. If I go on to the next one, it's going to bring it into its transfer position. And that we've already done. That was done at our setup. So that's already done for us. So we can see we've got clearances all round. We've got no particular problem on there. Everything's looking good. And it gives you that confidence because you can see everything up front. Okay, so I'm not going to go through a lot of other options on the actual programming side of things, but what I'm going to do is I'm going to simulate this now so we can actually have a look at it. And you've got various simulation methods, and we will have a look at a few of those on there as well. But I'm going to look at this in Solid at the moment. I'm just going to turn the holder off so we can watch this quickly on there. And at this point, I'm checking to make sure that what I've programmed is if you like, geometrically correct and showing it against the actual solid model which we've been working on. So we can see everything. What we don't see here is the machine kinematics and how it's moving to get there. But we're seeing everything is topologically correct on there. So we just spin that round. We embossed our logo on the other side. So it takes a few seconds just to go around there and see exactly what's going on. So this is just showing on there to prove that we've got no basic collisions, if you like. We're cutting with the wrong part of the tool. There's no holder collisions, and everything local to the part is looking good. So this gives us a very good opportunity to see exactly what's going on without having, if you like, to go into the full machine. We can see everything looking good locally.
And Mark, I'd like to interject as well here. I know you're going to show this in a moment, but We talk about multiple types of simulation for various different reasons. One of the things that Mark's going to show you in a moment is our automatic stock update and how powerful that is. So again, SolidCAM is trying to give you maximum visualization on what you're doing so that you actually get a more comfortable and more confident feel while you're programming the part.
Yeah, well, so what we're going to show on there now, everything looks good. We've got no collision, got no big bits of red on there, which would highlight a collision. But we're able to do a comparison to make sure that everything we're doing is correct. So we can set various levels on there. Now, the actual thread wasn't modeled into the solid model we had. So obviously that is showing that as a gouge, but it's not stopping us doing it. It's absolutely fine. We can go in there and show that. But what it also shows me, if I spin round and look at this end, is I've missed something. I haven't machined this opening here. So it's highlighting that to me as well. To see that, we've actually got a feature which I've missed on there. So let's just go back and put that in. So there's a couple of things on there first. We're going to add a tool to the library. So right at the beginning, I said we'll have a look at the tool library in a little bit more detail. So we'll do that as well, and also add this operation in. So first of all, this is a step file which I've just downloaded off the ISCAR website. So it's literally just out. We could do this directly from the tool library, but I want to bring this in to show it to you so you can see it as we're going along. So we've just got this drill which we're going to bring into SolidCAM. So all I've done is opened it. I haven't saved it, I haven't done anything else with it. It's literally just dragged and dropped into here. So from there, I can go into my tool library. So we're just going to edit the tool library. And there's three areas of the tool library. So there's tool components. It could be a holder, could be an insert, could be a shank, which can be built up in there. And we will get some bits out of there in a minute. We've also got assemblies, which is what this is. So this has got a tip on it and it's got a shank to it. It's multiple components put together. And then you can put them into machine setups. So for example, we could create a bank of tools purely for the ST20. So everything comes in populated and ready for us. So we're going to go into a tool assembly. And the one I'm going to go in, I've got one star turning tools already set up. And that's going to bring that into there. So this is just opened it at the moment. This is just a list of my tools, which I've got, which I use on a lot of star machines. So a nice little button on the left-hand side says import the tool assembly from the CAD. So it's just warning me to say that if I'm going to import it off of the SolidWorks screen, it needs to be the active window, which is fine, it is. So there's no problem. So we're going to bring this in as a milling tool. And you can see there, it's just literally just suck that across and put it into our tool library. So all I'm going to do now is to tell it that that's a drilling cutter. And the top part of it, I'm just going to assign as a shank. Dead simple. Nothing else to do. So we can just OK that. So that's now bringing it across. And now we can see that in our library here. So again, if I just turn the picture on, we can see that's already mounted in there. And all I'm going to do on there is, okay, that's imported. I'm just going to put it in my storage. So now it's sitting down over here. So obviously allocate whatever tool number you want. It doesn't particularly matter. That's just going to sit in my library. But we're in assembly library at the moment, so we could do a little bit more. We could make our life really simple. So if I come across to my components library, I've got with every, for example, star machine on there, there's a range of holders and that which are dedicated for it. So I can go into the ST20 and we've got various holders on here. So we're just going to go into boring on there and we'll grab the triple one on there, which is this holder here. And all I need to do is drag that onto the tool. And you can see there, our tool is now automatically mounted onto the holder. But if we zoom in a little bit, we can see, yeah, it's there, but it's not really there because it's missing a bit. We need to put a sleeve in there as well. So it's fine. I'm just going to go into a slightly different library. We'll go into the turret on there, and we've got some boring sleeves. I'm just going to drag one of those and drag that and put it on there. There's our boring sleeve. Now it's just mounted on there as well. Everything's being picked up automatically. And you saw me put the tool in there right at the beginning. So nothing, if you like, is cooked or anything like that. It's pure running live, and that's exactly how it works. So all I want to do now is I don't want that because of the way I potentially want to work, I need a bit more clearance because that's going to take the tool past center line and potentially cause a collision with here if I want to do some other work from the other turret. So I'm just going to move that, and I'm going to say, okay, we'll stick that in this position, or stick this in this position. It's so easy just to change the position of that holder on there. So that's now set in there. That's in my holder. That's there. I haven't got to do anything else to it. And we'll just save and exit out of there. So that's now in my library. It's all ready to use. I haven't got to do anything else. So I'm just going to close this down. As you see, I haven't bothered to save it. It's just done it. So yeah, fine, job done.
So Mark, this is really kind of pick and place or plug and play, isn't it?
It is literally just because the holders are set up with the mounting points on there. As soon as you pick a tool, it just goes straight in the right place. And those are all preset by us over here. So when they come in, it's there. It's open. So if users want to create their own holders and things like that, it's exactly the same. They're very, very straightforward. Okay, so that's in there now. So it's all ready to use. But I need to insert that into the instruction list somewhere. Somewhere down here, I've got to put those extra operations. So this is what I need to put in. I've got this extra diameter on there, which I haven't done. So if I take that, where do I put it down my list? Well, let's make life easy. If I put the updated stock on, it will show me or ghost me over the top the material on there. And I can now drag that down to any operation and see exactly the state at that point. So I'm going to drag that down to, say, here. So we've now got everything in there. So that looks like a good place to put it into. But I've got a machine control operation straight after, which is just moving the turret out the way. So let's put it in after that. So I can click on that as a reference to where I want to put this. Now, there's no reason why I wouldn't go in there and select a drilling operation and select the tool and obviously pick that on there. No reason at all. I can do that. But I want to be a bit clever with it as well, because the way I've set the tool up, I'm going to shift it off center and just break the edge as well. So I'm going to use that to do two operations and deburr it in one hit. So something which we prepared earlier on there and something which you can set up and something which is easily set up is what we call templates. And they could be just individual operations which we've saved, maybe with settings to do a specific feature or something, or even, as in this case, to do a combination of operations on there on a specific feature. And these are what we call process templates. So if I go into my library here, I've got process template, which is working on a 1/2-inch hole, 12.7 millimeters, but it's also set up to deburr it as well. So it's going to do two of those operations. And all I have to do is to drag that into my instruction list. It will ask me which datum to work off, which is fine. And then we pop it in there. So that's now adding those operations to the instruction list in the place I dropped it. So we can see they're now in there. So let's simulate those and see what it's done.
Now,
So,
Mark, is that only something that can be used with this particular file, or are these templates something that you can use generically?
They are typically something which you'd use generically. Where you saw me do the drag and drop there from a library onto the part, if I wanted to repeat something within the same part, I could actually drag operations onto different faces to get to duplicate stuff as well. So there's a lot more you can do internally, but this is like a generic. This is something I probably want to do over and over again. I might want to set these up with different sizes to do this, but this is something I can use on any part. And if I set this up with turning, it's another simulation. Very, very straightforward, basic simulation, very clear in terms of what's going on. So if I show you what's coming in now, so we can see our tool. And it's just coming in to just touch it because this is a generic template. This could be used on any part. So we need to set the depth for the individual part on there, but only for the first operation. The second one, where it's going in now off center, is just to break the edge. This is fine. We can leave that one alone, but I do need to change the first one. And it's just very simple. I can just come in here, edit it, go onto my levels on there, my technology, and say, okay, drill down to that face there, that edge. I haven't got to do anything else. That's it. So all the tooling, everything else is all set for me. I haven't got to worry about anything at all. So I'm just refreshing it. SolidCAM is built upon material management, specifically in turning, also capabilities in milling, but generally in turning. So it doesn't add tool paths to places where you don't need to. It knows all the material size all the way through. So when I've just calculated that, I've just refreshed the tree for myself as well. So it's just done everything in one hit. Now, if I simulate what's going on, so again, we'll do this in our turning simulation, and we'll do both operations. So that one and that one, just so you can see what's going on. So the light blue is obviously the material we've got left. There's our tool coming in, spot on. Just selected that off the model, then we're going off, and we're just going to break that edge. So saves us bringing another tool in. If there's no designation in terms of angle on there, in terms of break edge, it's a very, very good way of doing it.
So, Mark, this is really a kind of a semi-automated routine that allows a user to actually put in place the type of technologies that they prefer to use, correct?
I think that's a good way of putting it, because CAM companies or software people can put in things which they believe users might want, but typically everybody wants something different, and they want it flavored to the way they work. So this allows you to actually create defaults or to create operations to machine the parts as you want to, not how some software writer somewhere halfway around the world has decided it's going to be. This is done for you. So this is something you can do and set up for yourself and make SolidCAM easier and more automated for you, and not for somebody down the road, for the way you work.
Very good. Now, so you've done a lot of programming in this part, and it looks really easy to do that, but this is just kind of in straight order, isn't it?
This is just in straight order on there. So basically the method of programming, we've done all the work on between turret 1 and turret 3 on the main spindle. We've done the transfer, and then we're doing everything on this back spindle. That's the order which we've programmed it. So we now need to optimize that. So we can go into channel synchronization and just have a look. So this is how it's ordered. So we can see the path 1, path 3, and path 2 on there. And as you say, everything's in the order we programmed it. So our machining on the back over here in path 2 is happening after we've done the transfer. But in real life, obviously that's free time. We can do that while we're machining on the main spindle. So if I just click on the first operation after the transfer, we can optimize that and bring that up to the top, delete the weight mark, which is controlling that. And now we're doing all of this machining at the same time it's doing this over here. And what that's actually giving us is good feedback, because what I'm doing, I'm looking down here. I'm looking at the actual icons down the bottom. That's where my eye's drawing me, because I know if that's all I see in color, I haven't got any problems. All this machining is incidental. It's not being affected by anything working up here. So I can do all of that and save all of that time very, very quickly. So if I just undo that, for example, I just want to come back, you'll get a total machining time down here of 8.5 minutes. As soon as I've done that and copied that to the top, I've just lost half a minute. So that's the sort of time savings we've got just by doing something simple like that. And that's obviously why we want to have the machining. It's free time on there. But there's a few other things, bits and pieces I can do. So what we've got at the moment is it's effectively semi-optimized. It's not completely. And there's other things we can do in it. And to highlight that, I'm just going to jump out into the simulation. So this is the machine simulation of that part. And I'm just going to jump down, partway down the instruction list. So you can see down here, it's actually showing me all the operation names and what's going on. So I'm going to come down to this one here. And just by clicking on there, it's going to fast forward the simulation. So I haven't got to watch everything in the meantime. It's just going to go through it. It's still checking everything. It's making sure that everything is valid and we're not got any collisions and not got any limit switches appearing on there. So it's doing all the checks for me. I just haven't got to see it. So that's where we are. So now we can see the part in there. And I just want to highlight on there, we're now cutting a slot in the top, so I've just slowed that down a little bit. So you can see the turret 1 coming in and then machining that. And then we can see turret 3 coming in and machining the other one, which is fine, nothing wrong with that. And then we're going back to turret 1 and we're doing the helical hole in there.
Well, now, Mark, is there any way we can do those two operations at the same time?
Well, this is the ability with this machine, because we've now got the ability, we've got an independent Z-axis on here. So this will just follow what's going on there. So let me just jump out of that. We'll shut that one down and we'll come back into SolidCAM. So now I'm looking at this and I can see this is my operation I want to do at the same time as that one, but I've got a weight mark in the middle. If I just delete that and look down here, it's still good. It's still showing me it's good. So it now knows it can do this one and this one at the same time. And if I'm looking here, it's got a little S on the Z. It knows it's got into superimposition. It understands how the machine's actually got to work on here and has done that automatically. I haven't got to do anything else. That's it. So I could have done that one and I can do it again on this one, because with the 8mm hole which we're putting in, we can do that as well. Again, we can see the little S. Okay, I'm on a roll now. Let's see where we can take it now. I'm going to delete the next one. Let's see what we can do. So that's great. We're going to do some turning at the same time as drilling this hole. No, we're not. It's all grayed out now. We've got a problem. So this is now giving us that. But I can click on this and it will tell me what the actual issue is. So I can see on there, I've got a problem on here. And it's telling me that the same spindle speed, if I'm going to use turning operation on the main spindle and a drilling operation on the main spindle, they've got to have the same spindle speed.
Well, that makes sense.
So I need to do something about that. So I'm just going to, I'm good. I would just want to play around with that and come out of it. And if I look at the actual instruction list and to where it's, where it actually is, let me find it. It's here. So we're going to turn that OD. I'm hoping that's the wrong one because I've got these turned on. Let's make it a bit clearer. So we're going to turn the OD on there at the same time as we're turning drilling the hole in here. So we want to do those together. I've got an extra one on there, turn them. So we want to do those together. So to do those together on there, they've got to have the same spindle speed. So if I was to go into here and say, for example, change the tool data against it, we'll see this has got a spindle speed of 3000. If I do the same thing for the one below and change tool data, there's our mismatch. But that's close enough. I could probably get away with that. We'll drop that and make that the same. Okay, so I'm still looking at this, and I'm looking at this and say, okay, I've still got a problem. That's given me a traffic light against the setup, which indicates to me I've still got a synchronization problem in my channel. So, yeah, I can see that it's still grayed out. If I put the checking on there, it's now not got a problem with this operation. It's got a problem because it goes into superimposition to actually do those two together, but doesn't come out of it before it does the turret through. So that's fine. Let's take those two and we'll put a weight mark after it so that it can come out of superimposition. Now you can see everything's good. We're all lit up over here. We've now got it all optimized and our cycle times come right down now. So we can see all of that.
So, Mark, we don't really have to do any crazy stuff in the post-processor at this point either, do we? A lot of the systems out there have to create a bunch of black magic in their post, but we're giving all the information. I mean, I've been around CAM an awful long time through various systems over the years, and the one thing which, when I first got involved with SolidCAM, the amount of information being passed from SolidCAM to the post-processor way exceeds anything I've seen before. It's so pretty amazing, isn't it?
Yeah, so the post-processor writers are given all the information up front. So this is on a FANUC control on there, obviously on a Citizen with Simcoe control. You'll have different problems on there, but with all the information being provided for you by SolidCAM, it does make our job a lot easier to actually generate these, to get them working exactly as the customer wants them.
And we've got some pretty good time savings here, don't we?
Absolutely. We've just saved a minute on here. And when we're talking about machining times on some of these parts, that's a substantial saving on there. Yeah, most of the machining on here, in terms of times, we can see on there, if we come down, or where are we? We've got, we're doing the wrapped profile on here. That's taking 2.5 minutes on its own. So that's just being something which we put on there to make it look a really sort of sexy part on that, which probably wouldn't be on a lot of other parts. But that's something which is certainly possible with inside SolidCAM and does show it off very well.
Yeah, but think about that a minute on, if you're running 10,000 of those parts, then that's a lot of time savings right there. Absolutely. Just by shuffling some things around.
Yeah. So if I just highlight that for you. So what we've done is actually made those two operations work together. and SolidCAM's happy with it. It's seen it. It's done it both together on there, but we haven't really seen it. We haven't really proven it that it's not going to cause any problems. So I'm going to jump down to that in the instruction list now, into the machine simulation, and see exactly what's going on. So this is now, again, fast forward, exactly the same as we did just now. And that's going to bring that up for us. So that's now bringing us up into the situation. Now you can see we've got both turrets working or in position, ready to go. So if I hit the play button now, it's now understood. And if I look at if I spin that round just a little bit, as it's going into the next one, we've got a Z3 on the lower turret compensating for the movement in the part, which is being used, because obviously we haven't got a Z1 on the upper turret. So that's been done automatically. We haven't had to do anything apart from just marry those two operations together. And again, now we're doing the turning and drilling at the same time as well. So again, all of this is possible. All of this is visually checked and everything else. We can see everything which is going on. Okay, so we've come out of there. So we've done all of that. We've all optimized it or something. But you've seen me play around with a couple of things on there now. So I've tried this, does that work? Tried that, does this work? And there's no problem at all in SolidCAM doing trial and error. Does this work? Does that work? It's very, very quick and easy. But if I'm doing that, then maybe I want to save myself in certain areas. So we can export various options on here so we can play around. Oh, I'll save that before I go and try something else. So we can export and we can import it back in. So if I just bring back in the optimized onto here. So this is fully optimized on there. We can see the superimposition, everything going. We can now, we've simulated it. We've done the synchronization on it. We can now generate the code. So this is now custom code ready for this machine. We bring this in here. We can cut it and it's all ready to go. So this is now generating that for us. So this has actually brought us into Simcoe, and we can see the code being generated and what we've got. So this is code which is written for the star machines, as I say, but we write them first of all as a generic. So we copy Star's recommended programming routine for a start, and then if customers want them, then obviously we'll tweak it to suit. So this is just in showing all the code coming through. I can also bring it up in what we call Sync Master, which will actually show the channel separation on there with all the weight codes and everything else. So again, we can lay this out and see exactly what's going on to check to make sure that we've got no mismatch of codes, because obviously that's an error on the machine. And this has just come straight out, and that's the job done. So we've taken the part from a solid model, we've programmed it all the way through, visually checked everything, whether it's just in machine preview. We've done the simulations on it, we've optimized it in channel synchronization, and now we're ready to press the start button on the machine.
Very good, Mark. Very good. That's absolutely impressive. And as we were talking about earlier, you get to see all of this. You get to, kind of watch how it works while you're programming, which is going to give you a lot better efficiency in your programming. So not only are we improving the efficiency at the machine itself, we're also improving the efficiency in the engineering department, aren't we?
That's it. Yep. Yeah, it's basically savings across the board on there because, okay, in a lot of places you'll find there's, certainly in the UK, I'm guessing it's the same there. A lot of these places, these shops with the sliding head, the Swiss turns on there, they're still programming a lot of these machines by hand because the software just hasn't been strong enough to support it properly. And you've got very skilled people on the machine programming it. This gives you the opportunity to actually take that skill, because we're not replacing this, we're helping now. We're making life easier for the programmers to take that away. The machine's much more efficient because it's now running all the time, and we've got an easy mechanism there. And it's also an easy mechanism to bring new people into this technology as well. Right,
very much so. Well, thank you for showing that. Certainly appreciate that. And at this point, just kind of want to talk just a little bit briefly about SolidCAM going forward. Our development department is always working on continuous improvement. We do want to hear from our customers. And so we take a lot of our suggestions for how we can enhance the software and how we can make it better and more effective for our users by actually listening to those users. So again, let me bring you back to my screen here for a second. And we will go back to this last slide. And if anybody has any questions whatsoever, again, you can interact with us at www.solidcam.com. And you can also contact us by telephone at the 866-975-1115 extension 2, and we'll get you in touch with the right people to serve your needs. At this point, I'd like to hand it back to Derek, and let's go over some question and answers. I see that there are several that have hit the board, and we'll see if we can't answer your questions for you.
Yeah, super. Ken and Mark, thanks for that presentation. It's just me maybe, but Mark, your point about deburring on the machine was particularly interesting. Like one of the big benefits of this type of equipment is dropping parts complete. Well, if it still needs to be deburred, it's not complete.
It's not complete, no.
Right.
Exactly.
So yeah, we've got we've received some questions. There's still time for any viewers to enter some additional ones. But I'm going to kind of sneak up on this one because it piqued my interest. I've written about iMachining for milling before. Just curious, can that concept be applied to turn mills and Swiss types?
Absolutely. It's really great too, because one of the things about iMachining, because of everything it does, most of the time you see our videos and stuff and our demonstrations on iMachining, the tool's moving super fast and we're removing a lot of material really quickly. And that's pretty impressive. But one of the other things that we sometimes neglect to show, and we probably should show it better, is that a lot of times on Swiss machines, you're working with very small tools. And iMachining is absolutely fantastic at protecting those tools. So we can go in and we can get material out of the way quicker than you will with a standard tool path, and at the same time make your tool last longer, even when we're talking about these really tiny, very delicate tools that we're using in some of the cases, like with medical components and things of that nature. So yes, absolutely, iMachining can be done and both in XY as well as in polar coordinates, where we have to use the X and the C. So
cool. Another question here. Let me read this here. When adjusting the pickoff location by moving the part in and out of the sub spindle, does the software keep it within machine travel limits, within proper clearance automatically, or do you have to do that, do the simulation to see that?
Mark, you want to take that one?
Generally on there, it's going to be, there's no reason why it can't be built in to detect that, but generally we would expect that to be done as because it also depends on where we're parting off from. It's not just a case of where we're picking off from. It's because the Z2 axis could be going up. It's going up to a set position, but that set position is relative to Z1. So it might be dependent on what we're doing on there. So when we're doing the setup on there, it's not going to know at that point, but it would do as soon as we actually came to use it.
Sure.
Another question from someone who appreciates this webinar. Is it possible to program a tool measurement check before finishing operations? Yes.
That would be an MCO that we could use to push the tool over to, for instance, a sensor and have it do the routine that it needs to do to check to make sure the tool's not broken. Absolutely.
Okay, another question. How many channels do you support?
Theoretically, it's unlimited. As you saw today, it was a 3-channel. I have been involved in some conversations where we've done a 4-channel machine.
Yeah, we've got 4-channel here.
Yeah, I don't know that we've ever seen a 5-channel machine, but the way the software is constructed, there is no limitation to that.
Another question. So the question is, do you run all types and brands of Swiss CNCs? But I guess another question is, like, what machines do you post to?
We post to anything that we get a hold of a manual on and see what we need to do. Our post processor is very open sourced and very capable. And as far as I've seen, I don't know that there's any machines that are running G code and even into some of the conversational codes where we haven't been able to write code to them.
Another question here. Does SolidCAM work with any other CAD systems besides SolidWorks?
SolidWorks and Inventor right now are our two primaries, and we are currently in process working on another integration for Solid Edge, which we hope to see potentially third, fourth quarter of this year, maybe into first quarter of next year.
I think Mark maybe touched on this a little bit, but does SolidCAM support superimposed motion?
If you're looking at the video now, it's actually in the middle of something. Yes. So it's actually you actually caught me right at the right time. That was actually doing drilling on the lower turret as it was doing turning on the upper turret. And obviously the superimposition part of it is adjusting the Z3 on the lower turret to match where the Z1 position is being moved to. So yeah, superimposition. And you saw when I actually came to do it, it's just a case of marrying up those operations. You don't actually have to do any more than that. If it's valid to do it between those two operations, SolidCAM will allow you to do it.
Yeah, this is actually where some of the axis pattern stuff comes in very handy, because it automatically tells the system, which axes are allowed to work with each other's and which ones are prohibited. So it really does become more, plug and play type functionality. You don't have to set special parameters or create crazy things to make it happen. It's a matter of synchronizing it in the channel synchronization. So it's very powerful.
So we're at the top of the hour. It looks like we have one more question. Does SolidCAM support solid tools from the tooling manufacturers?
Yes, absolutely. And that's what Mark showed you. And that's, very, very easy to do. We've set up a couple of different utilities to make that happen very easily, and always working more on building those libraries and working with those tooling partners to kind of have those libraries available.
Great. Guys, this has been awesome. As Ken mentioned before, you have contact information on the screen. You can visit the website, phone number to call if you would like as well. But that's all the time we have for the webinar. I appreciate you all coming out. On behalf of Production Machining and SolidCAM, thanks for joining us, and enjoy the rest of your day.
All right. Thank you, everybody.
Thanks a lot.